Hello, welcome back to another video here at Math Rocks with Mr. Cox. This video is dedicated to solving systems. So you may be asking yourself, well, what is a system? Well, in this case, it's going to be two different equations, y equals 2x plus 5 and y equals negative 3x minus 2. These are both lines, and what you're trying to do is you're trying to find the intersection of those two lines. You can do it really one of two ways. One is graphically, and the other way is algebraically. And this video is all about solving the system algebraically. So stick around and find out how it all works. Let's get it on! So how does solving systems algebraically work? What I have over here is I have a couple of equations, y equals 2x minus 1 and y equals negative x plus 5, and these are both lines. And because they're both equal to y, you can set 2x minus 1 equal to negative x plus 5. So you'll see that right over here where I've done that. And I've gone ahead and solved for x by adding x and adding 1 to both sides. You get 3x equals 6. And therefore, after you divide by 3, you get x equals 2. And remember, you're trying to find the coordinate, so x equals 2 would not be enough. And so you can plug in that 2 into either equation. So if you plug in a 2 here or plug in a 2 over here, you should get the same thing. And in fact, it doesn't matter which one I pick, I get 3. Now, if we don't get the same number each time, that's a problem which we'll talk about later in the video. But we did get 3 in both cases here, so that means y is 3. So the answer is 2, 3 as a coordinate. And you can see over here, I've also gone ahead and shown it graphically where we do indeed get the exact same answer using a graph. So that's how you do it with lines, pretty straightforward, and hopefully you've already seen that in an earlier algebra class. But we're going to go ahead now and look at something a little more difficult. This time the system is going to actually have a line, that's the second equation here, but this first one is going to be a parabola. And so just to give you an idea of what that might look like, here's your parabola. Your line might look like this, in which case it's going to cross twice, not just once, but twice. It is possible maybe it just barely nicks over here and hits once, or maybe it's a line down below this and never actually crosses the parabola. So it's either going to have two solutions or 1 or 0. So let's go ahead and solve it algebraically. They're both equal to y, so I'm going to go ahead and set them equal to each other. So I have parentheses x minus 4 squared equals negative x plus 6. All right, so let's do this first. Let's go ahead and square x minus 4. And I'm going to actually show that over here using generic rectangles because a lot of people actually blow this. And you're going to have x minus 4 times an x minus 4 when you do this. And inside the box, x times x is x squared. X times negative 4 is negative 4x. And negative 4 times x is negative 4x. And then finally, negative 4 times negative 4 is 16. So most people know, hey, if I square x, I get x squared, and if I square negative 4, I get 16, but they forget the negative 8x when you combine this together. So I'm going to go ahead and write that right over here. So I get negative 8x plus 16, and then equals negative x plus 6. All right, so let's go ahead, and we want to have it equal to 0 on one side so we can factor or use the quadratic formula. So to do that, we're going to need to add x and subtract 6 on both sides. So I'm going to go ahead and do that. Add x, subtract 6. So now I get x squared minus 7x, and then I get plus 10. Now, some people are more advanced users already. I'm going to go ahead and show you the advanced user way of doing this. You can use a box and a diamond problem to do this, but basically you're looking for two numbers that multiply to be 10 and add up to be negative 7. So I'm going to show that here in just a diamond problem. So I'm going to put my 10 right here and my negative 7 here. And so when we're thinking of these two numbers, they have to multiply to be 10. So it ends up being negative 2 and negative 5 because they also have to add up to be negative 7. Therefore, when we go ahead and actually factor this out, we're going to get x minus 2, and then we're also going to get x minus 5 equals 0, which means x would either equal 2, and then x would equal 5. So we're going to end up having two coordinates here where this line actually crosses the parabola. Let's plug in a 2. If I plug in a 2 here, 2 minus 4 would be negative 2, and negative 2 squared would be 4. And if I plug in a 2 into the other equation, negative 2 plus 6 is also 4. So it didn't really matter which one I picked. So one of my answers here is going to be 2 comma 4. And then if I plug in a 5, 5 minus 4 is 1. 1 squared is 1. And if I had chosen the bottom equation, I would get negative 5 plus 6, which is also 1. So my other answer is 5 comma 1. So what this means is the parabola and the line are going to meet two different spots, and those points are 2 comma 4 and 5 comma 1. And just to show you graphically, I went ahead and I put those equations into Desmos, and lo and behold, 2 comma 4 and 5 comma 1. So whenever you get a chance and you have access to a graphing calculator or a computer and can use something like Desmos, do it, and then you can also check graphically to see if your equation answers are actually correct. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. The second system I wanted to show you was, well, what if we had a square root graph in a line? So square root graph might look something like this, and a line might look something, I don't know, like this. It is possible, by the way, this crosses once, it is possible maybe to get the line to cross here, maybe over here. So could it cross twice? Yes. It also might cross never by maybe a line down here or something like that. So we're either going to get 0, 1, or 2 solutions here. Once again, they're both set equal to y, so let's go ahead and set them equal to each other. So the square root of x plus 5 equals x plus 3. All right, so now what we're going to do is we need to undo the square root. So when we do that, we're going to get squared on both sides. On the left side, we're only going to get x plus 5. On the right side, it's going to be x squared plus 6x plus 9. Now I know, once again, most of you know x squared is x squared and 3 squared is 9. So where does the 6x come from? If I do that the generic rectangle again, not a diamond problem, over here, and I put in x plus 3 and also x plus 3, you'll notice I'm going to get x squared, a 3x, and also a 9. So that's where the 6x comes from. And we need to go ahead now and set equal to 0, so I'm going to subtract x and subtract 5 on both sides. So here's my subtract x, my subtract 5. So I get 0 equals x squared plus 5x plus 4. So to factor this, we're going to need to think of two numbers that multiply to be 4 and add up to be 5. So I'll show that here in a diamond problem. I've got my 4 and I've got my 5. So what multiplies to be 4? It's either going to be 1 and 4 or 2 and 2. And it's going to be 1 and 4 because 1 plus 4 is 5 and 1 times 4 is 4. So this is going to factor into x plus 1 and then also x plus 4. Which means, to use the zero product property, that means x is going to have to be equal to negative 1, or x is going to be equal to negative 4. So now it looks like we have two solutions. So maybe this line, when it gets drawn in, maybe it does cross twice. So let's check. If I take my first equation, plug in a negative 1, negative 1 plus 5 would be 4. Square root of 4 would be 2. If I plug this negative 1 over here, I get negative 1 plus 3 would be 2. So it didn't matter which equation I put into, I got a 2 each time. So now my solution is negative 1 comma 2. Now let's try negative 4. If we try negative 4 here, negative 4 plus 5 is 1. The square root of 1 is 1. If I try negative 4 in the other one, negative 4 plus 3 is negative 1. Because we don't get the same y value, what happened is this answer over here is what we call an extraneous solution. Looks like a solution, but it turns out not to be one. And that has to do really with back here when we were squaring at the very beginning, it has a tendency to create extra solutions here. So in this case here, there's only one solution here at negative 1 comma 2. So make sure you check your answers that you get the exact same y for either equation. And if you don't, it's an extra answer that actually does not work. So cross it off and don't include it. And lo and behold, you'll notice here when I actually graph this using Desmos, I got the answer of negative 1 comma 2 just as we got in when we solved it algebraically. So I hope you learned a lot from this video about how to solve equations algebraically. There is going to be a part 2 about how to solve them graphically, so make sure you see that video as well. Thanks for watching.